My name is Gulmira Bekmanova. I am an associate professor of LN Gumilev Eurasian National University, Department of Computer Science and Information Security. Welcome to Database Theory course. Relational databases is one of the most powerful tools for database developers. At the end of this course, you will be able to organize and store your application data. Today we will have a lecture about structured query language. SQL is a language for querying and populating databases. You will learn how we use SQL to fetch data out of database. We will discuss data types, domains, tables, create, select, delete, update, and other SQL commands.
Structured query language, SQL. Objectives. The objectives of our lecture are: explore basic commands and functions of SQL, how to use SQL for data administration, to create tables, indexes and views, how to use SQL for data manipulation, to add, modify, delete and retrieve data, how to use SQL to query a database to extract useful information. Structured query language, SQL, is a language that provides an interface to relational database systems. SQL was developed by IBM in 1970s for use in System R and is a de facto standard, as well as an ISO and ANSI standard. SQL is often pronounced SQL. The development of SQL is governed by standards. A major revision to the SQL standard was completed in 1992, called SQL 2. SQL consists of three parts. The first one is DDL, Data Definition Language Statements. Some examples: create, to create objects in the database. Alter the structure of the database. Drop, delete objects from the database. Truncate, remove all records from a table. Comment, add comments to the data dictionary. Grant, gives user access privileges to database. Revoke, withdraw access privileges given with the grant command. The second, most important part of SQL is DML. DML is data manipulation language. Some examples: select construction, retrieve data from a database. Insert command, insert data into a table. Update statement, updates existing data within a table. Delete statement, deletes all records from a table. Call function, call a PL SQL or Java subprogram. Explain plan statement, explain access passed to data. Log table command, log table command control concurrency. DCL is data control language statements. There is a third part of SQL. Some examples: commit, save log done. Save point, identify a point in a transaction to which you can later roll back. Roll back, restore database to original since the last commit. Set transaction, change transaction options like what rollback segment to use. SQL tables. The schema of a table is the table name and its attributes: person, identifier, name, age, and credit score. A key is an attribute whose values are unique. In this table, there is identifier attribute. We underline key for convenience. SQL statements or commands. The first one is create table. Next one, insert into. delete from, update, select. Creating relations in SQL. Create table statement. You can see the example about create table person with the next attributes: identifier char 11 not null, name varchar 50, age integer, credit score integer, primary key identifier. It is possible to have many candidate keys specified using unique, one of which is chosen as a primary key. Domains. Create domain statement. The create domain statement names a new domain and defines the domain set of valid data values. A domain can be defined as follows: create domain upnum char length 3. There is apartment number. Create domain key code char length 4. There is door key code. Constraint 1. Check value is not null, not differable. Constraint 2. Check value between 1000 and 9999. Differable initially immediate. The optional domain constraint list clause shows the rules that restrict the domain set of valid values. Creating relations in SQL. Create table statement. Create table apartment with next fields: number. There is upnum, not null. If you remember, upnum is name of the domain, the previous slide. Rooms, integer, key code. There is domain 2, key code, monthly rate, money, primary key, number. Next example shows us how we can add a column to a table. Alter table apartment, add flu integer. Creating relations in SQL. Create table statement. Cross references table. Relationship in the ER model. You can see ER diagram with three entities: person, tenant, and apartment. And you can see the example about create table tenant. Create table tenant, tenant ID char 11 not null, upnum not null. If you remember, upnum is the name of the domain. Login ID varchar 20, password varchar 20, since date, until date, constraint fk tenant ID foreign key, tenant ID. There is a references person identifier, constraint fk upnum foreign key upnum, references apartment number. You can see that our table tenant is cross references table between two another tables. Adding and deleting tuples. Insert a single tuple using insert into person next attributes: identifier, name, age, and credit score. Values. In the brackets, we show the real values. All of these values are strings, not numbers. Delete all tuples satisfying some condition. In our example, name is equal Homer Simpson. There is our condition. Delete from person P. P is alias definition. Usually, alias is short name of our table, where p.name is equal Homer Simpson. SQL queries select statement. I think that all of us have already listened about select construction. There is the most popular construction for database designers. The format: select names of attributes from names of tables where condition. Selecting rows with conditional restrictions. Comparison operators. You can see traditional comparison operators and their meaning: equal to, less than or equal to, greater than or equal to, not equal to. Arithmetic operators, the rule of precedence. Table shows us the arithmetic operators, their symbols on the left side, and their description. Add, subtract, multiply, divide, raise to the power of. Some application use instead of. Operators between, used to check whether attribute value is within a range. Is null, used to check whether attribute value is null. Like, used to check whether attribute value matches given string pattern. Some queries. SQL uses is or is not to compare nulls because it considers each null value distinct from other null. Query 1. Retrieve the names of all employees who do not have supervisors. The text of query. Select fname, lname from employee where supper SSN is null. Note: if a join condition is specified, tuples with null values for the join attributes are not included in the result. Special operators. In, used to check whether attribute value matches any value within a value list. Exists, used to check if subquery returns any rows. Next example. It is also possible to use an explicit enumerated set of values in the where clause rather than a nested query. Query 2. Retrieve the social security numbers of all employees who work on a project number 1, 2, or 3. Text of query. Select distinct ESSN from works on where P&O in 1, 2, or 3. Next example. With exists. Exists is used to check whether the result of a correlated nested query is empty, contains no tuples or not. The text of query 3. Select fname, lname from employee where exists. In the brackets, you can see subquery. Select all from dependent where SSN is equal ESSN and fname is equal dependent dash name. Aggregate functions. If you want to calculate something in a query, you can use aggregate functions. There are 5 different functions in SQL. The first one is count, the number of rows containing non-null values. The second one is min, the minimum attribute value encountered in a given column. The third one, max, the maximum attribute value encountered in a given column. The fourth one, sum, the sum of all values for a given column. And the last one, AVG, the arithmetic mean average for a specified column. Aggregate functions. Let's see the examples for aggregate functions. Include count, sum, max, min, and average. Query 5. Find the maximum salary, the minimum salary, and the average salary among all employees. The text of query. Select max from salary, min from salary, AVG from salary, from employee. Query 6. Find the maximum salary, the minimum salary, and the average salary among employees who work for the research department. Text of query. Select max from salary, min from salary, average from salary, from employee, department, where DNO is equal D number and D name is equal research. Let's see next 3 examples with animation of SQL queries. To illustrate 3 SQL queries. Query 7. Simple select one table. Query 8. Select with conditions one table. Query 9. Select requiring a join operation. Observe how they are implemented. Measure the number of row operations. You can see 2 tables with the data, an instance S of sales and instance R of reserves. S, instance of sales. Our task. Query 7. Find the names and age of all sales. SQL query 6. Select s.sname, s.age from sales S. S, if you remember, alias name. The corresponding SQL query. Now animate the execution of the SQL query. Result. In our result, we will have 2 columns, sname and age. Let's start. Our query result is also a database table. S, instance of sellers. First row, Dustin. Name is Dustin, age 45. We add this row to our result table. Output only the required fields in this entry. Next step, Laba. His age is 55.5 or 0.50. Add this row to result. Rusty, and his age 35. We add this row to the result. Step 4. Zorba. His or her age is 16. There is very young person, and we add this row to our result table. Horatio, and his age 40. We add these rows to and end of the algorithms. Summary of query 7. Result of SQL query is another table, derived from original table. A simple analysis shows this takes projection n row operations, where n is size, the number of records in table S. This query is also called a projection. It is the same as the year-project primitive. It simply selected a subset of the columns. S instance of sales. Task. Query 8. Find all sales with a rating above 7. The corresponding SQL query. Select s.sid, s.sname from sales S, where S rating greater than 7. Now, animate the execution of SQL query. Our CPU will check condition. You can see S instance of sales with red column rating. Our result table will have two columns, SID and SName. Query result is also a database table. Step 1. Let's check, is the rating of Dustin greater than 7? Is the 7 greater than 7? No. Condition is false. Do not output this entry. Step 2. Laba, and his rating is 8. Is 8 greater than 7? Yes. Condition is true. Output this entry. Let's add Laba to our result table with his ID. Step 3. Let's check Rusty with his rating, rating 10. Is 10 greater than 7? Yes, of course. Condition is true. Output this entry. We add Rusty to the result table. Let's check Zorba. Is 10 greater than 7? Yes, of course. We add Zorba to our result table. And last row, Horatio. Let's check. His rating is equal 9. Is 9 greater than 7? Yes. Let's add Horatio to our result table. End of algorithm. Summary of query page. Result of SQL query is another table. Row inclusion is determined by where clause. A simple analysis shows. This takes select n row operations, where n is size, the number of records in table S. This query can be decomposed into an eSelect followed by and eProj primitives. We have two tables of database, sailors and reserves. Query 9. Find the names of sailors who have reserved board number 103. Select s.name from sailors s reserves where s.sid is equal a.sid and a.bid is equal 103. There is corresponding SQL query. This query requires information from both tables S and R. To answer this query, a join operation needs to be performed. Condition: s.sid is equal a.sid. This specifies how S and R are to be joined together. Overview. A join operation works as follows. For each row in table S plus, try to join with each row in R. Match the where conditions. Analysis. So, a join takes O and M row operations, where N is equal size of table S and M is equal size of table R. result table will have one column as name. Let's compare the first rows of table S and the first rows of table R. S.SID is equal 22. R.SID is equal 22. S.SID is equal R.SID. Our first condition is true. Let's check the second condition. R.BID is equal 101. R.BID not equal 103. Condition is false. Do not output this entry. Next step. Let's compare the first row from the table S and the second row from the table R. S.SID is equal 22. R.SID is equal 58. S.SID is not equal R.SID. Condition is false. Do not output this empty. Third step. S.SID is equal 31. R.SID is equal 22. Condition is false. Do not output this empty. Next step. S.SID is equal 31. R.SID is equal 58. S.SID is not equal R.SID. Condition is false. Do not output this empty. Let's check. S.SID is equal 58. R.SID is equal 22. S.SID is not equal R.SID. Condition is false. Do not output this empty. And our last step. S.SID is equal 58. R.SID is equal 58. S.SID is equal R.SID. R.BID is equal 103. Bingo! condition is true, output this entry. And now we add Rusty to our result table. End of algorithm. Summary of query 9. Result of SQL query requires information from two tables. A join operation is necessary. Analysis shows this takes selection and m row operations, where n is size the number of records of table S and m is size the number of records of table R. Joins are expensive operations. This query can be decomposed into an eJoin, then eSelect, after that eProject primitives. Before then we will start next topic about DCL, data control language. We need to understand basic concepts about transactions. I think all of us have already listened about transactions. When you used, for example, cache machine showed you different messages that your transaction was successful or not. And maybe you think about this. What is the transaction? Transaction is a series of operations that are performed as one logical unit of work. Transactions allow SQL Server to ensure a certain level of data integrity and data recoverability. The transaction log, which every database must have, keeps a record of all transactions that make any type of modification, insert, update or delete to the database. SQL Server uses this transaction log to recover data in case of errors or system failures. ACID is an acronym for atomicity, consistency, isolation, and durability. SQL Server ensures that either all data modifications in a transaction are completed as a group if the transaction is successful, or that none of the modifications occur if the transaction is not successful. In other words, SQL Server ensures the atomicity of your transactions. ACID consistency. SQL Server also ensures the consistency of your transactions. Consistency means that all data remains in a consistent state after a transaction finishes, regardless of whether the transaction failed or was completed successfully. Before a transaction begins, the database must be in a consistent state. After a transaction occurs, the database must be in a consistent state. A new state if the transaction succeeded or if the transaction failed. The same consistent state it was in before the transaction started. ACID isolation. Isolation means that the effects of each transaction are the same as if the transaction were the only one in the system. In other words, modifications made by a transaction are isolated from modifications made by any other concurrent transaction. If a transaction fails, its modifications will have no effects because the changes will be rolled back. SQL Server enables you to adjust the isolation level of your transaction. Transactions isolation behavior depends on the isolation level you specify. You can choose the own isolation level for your system. ACID isolation levels. SQL Server supports 4 levels of isolation. A higher isolation level increases data accuracy, but it can reduce the number of concurrent transactions. A lower isolation level will allow more concurrency but will result in reduced data accuracy. The 4 levels of isolation from lowest to highest are: read uncommitted, lowest level of isolation. At this level, transactions are isolated just enough to ensure that physically corrupted data is not read. Read committed, default level for SQL Server. At this level, reads are allowed only one committed data. Committed data is data that has been made a permanent part of the database. Repeatable read, level at which repeated reads of the same row or rows within a transaction will achieve the same results. Serializable, highest level of isolation. Transactions are completely isolated from each other. At this level, the results achieved by running concurrent transactions on a database are the same as if the transaction had been run serially. ACID durability. The last ACID property is durability. Durability means that once a transaction is committed, the effects of the transaction remain permanently in the database, even in the event of system failure. The SQL Server transaction log in your database backups provide durability. If SQL Server, the operating system or a component of the server fails, the database will automatically recover when SQL Server is restarted. SQL Server uses the transaction log to replace the committed transactions that were affected by the system crash and to roll back any uncommitted transactions. If a data drive fails and data is lost or corrupted, you can recover the database by using database backups and transactions log backups. If you plan your backups well, you should always be able to recover your system from a failure. Unfortunately, if your backup drives fail and you lose the backup that is needed to recover the system, you might not be able to recover your database. Conclusion. Today we discussed structured query language, SQL. We discussed history of this language and two parts of this language: DDL, data definition language statements, and DML, data manipulation language statements. I explained data types in SQL, SQL domains, tables, SQL statements. We have created relations, created domains, and today we saw cross-references table with their relationships. Adding and deleting tuples, SQL queries, conditional restrictions, the rule of precedence, and syntaxes of special operators, like between, with null, and like. We saw different examples about queries and aggregate functions like count, min, max, sum, and average.
And now time to the questions, and I want to ask to Diana, what is SQL and how we use it in our life? Thank you. Diana.
Yes, thanks. SQL it's a language for special database, and we can use it for creating tables and changing information for them, for business maybe, and for lessons too.
Thank you to Diana. You are right. You have an excellent answer. And I have next question for Dinara. What is the difference between DDL, DML, and DSL?
DDL, DML, and DCL are the types of SQL language. DDL is data definition language. Create, for example, such operators such as create, used for creating tables, relate to this type of SQL. Next is DML. It's data modification language. The most common operator of this type of SQL is select. It's used for selecting records from the table. Next is DSL. It is data control language. The most common operator of this type is commit. It's used for saving state of our database.
How does one eliminate duplicates from the table? Can you answer me, Gauhar?
In order to eliminate duplicates from the result, we should use select distinct operator.
Questions for students' self-work. Please prepare your answer and send me by email before next week. Thank you. The first question. How does one generate primary key values for a table? When you answer to this question, please give me a full explanation and show me example with using SQL query. Thank you. The second one. How does one get the time differences between two date columns? Please show me example 2 and give me explanation to this question. Thank you. The third one. How does one add a day, hour, minute, second to a date value? Please show me example 2 and give me explanation. Thank you. Can one drop a column from a table? Why? Can one rename a column in a table? Give me explanation of your answer. You can show example if it's possible. Thank you. That's all.
Thank you for your attention. See you next week.